Hello everyone, so today we're going to go over how to solve a system of 3 equations. So I have this problem for me right here. If you need to, go ahead and copy the problem and let's work through this together. So if you recall, when we did system of equations with 2 equations, one of our methods was elimination. And in order to use elimination, we needed opposite coefficients. Let's take a look at our variables. So my x variables, I have 2, 6, and -4. There are no opposite coefficients here. For y, I have 1, -3, and +4. Again, those are not opposites. However, if we take a look at z, I have +1, -1, and -1. Those are opposite coefficients. So now we just need to think about, well, how can I combine those together? I'm going to label my equations. Equation 1, equation 2, and equation 3. What I noticed is that equation 1 and equation 2 have opposite coefficients, right? Take a look at them. They have opposite coefficients. So I want to combine equations 1 and 2. Let me copy them down. 2x plus y plus z equals to 15. And then 6x minus 3y minus z equals 35. These are opposite coefficients, so if I add these 2 equations together, our z's should cancel out. Let's add straight down. 2x plus 6x is 8x. This is a 1y plus -3y gives us -2y. And then 15 plus 35 gives us 50. All right. Let's take a look, see if you can figure out what other 2 equations I should combine. When you're ready, go ahead and unpause, and then I'll walk you through the next step. So if you picked equations 1 and 3, you are right. We cannot combine 2 and 3 because they are the same, right? We need opposite coefficients. So again, I'm going to copy down equations 1 and 3. 2x plus y plus z equals to 15, and equation 3 is -4x. Plus 4y minus z equals -14. Again, since I have opposite coefficients, I can add them together. Our z's will cancel out. And then we're going to add our other variables together. 2x plus -4x gives us -2x. And then y plus 4y gives us 5y. 15 plus -14 gives us 1. And here's what we're going to do now with these 2 new equations. Simply copy them down onto this bottom space here. And now what we have made is a system of 2 equations, and we know how to solve this. We've been doing this all last week. If you don't remember, go ahead and watch the video on how to solve a system of equations using elimination. But what we're going to do is we're going to try to create opposite coefficients. We do this using our crisscross multiplication method. So I do know I need to multiply the top by 2 and the bottom by 8. And then I want to ask myself the question, well, do I need to change one of their signs? I have the top equation right here is positive. And the bottom one is negative. That means I do not need to change their signs. I can go ahead and just multiply. Please make sure when you are multiplying, you are distributing to every single term. A lot of you guys forget to do that. So 2 times 8x is 16x. 2 times -2y is -4y. And 2 times 50 is equal to 100. Same thing on the bottom. 8 times -2x is -16x. 8 times 5y is +40y. And 8 times 1 is 8. You guys know that I always like to give myself like checkpoints, and here's a checkpoint for me right now. Do we have opposite coefficients? If you do not have opposite coefficients, you've messed up somewhere, okay? So over here, I see I have opposite coefficients. That's my checkpoint. That means I can go ahead and add my 2 equations together. And that should cancel out my x's. Now let's add these. -4 plus 40y is going to give us 36y. And then 100 plus 8 gives us 108. And now we just have a simple one-step equation. Solve for y, divide both sides by 36. You get y is equal to 3. This is a system of equations, so we are not done. So now what I'm going to do is take one of my equations. I'm going to take the top one. 8x minus 2y is equal to 50. And what we're going to do is we're going to plug in for y because I already know what that is. So 8x minus 2, and instead of y, we are plugging in 3, and that's supposed to equal to 50. Let's distribute. 2 times 3 is 6. And then we're going to add 6 to both sides. This is now a two-step equation. So 8x is equal to 56. One more step, divide by 8. X is equal to 7. Almost there, because if we think back to the beginning, yes, this was a system of equations, but it was a system of 3 equations. I had 3 variables. So go ahead and take a look at the 3 equations all the way at the beginning, equation 1, 2, and 3, and pick the easiest equation to use. For me, that's going to be the first equation, which is going to be 2x plus y plus z equals to 15. And we are going to plug in for each of these. I have my y solved for, and I have my x solved for. I still need to solve for z. Okay, let me get these colors down here. All right, so I have 2. My x I got was 7, right? I'm not making that up. This was my x value right here. So I'm going to plug that in, plus my y value I got was 3, plus z equals to 15. 14 plus 3 plus z equals to 15. This is 17 plus z equals to 15. Minus 17 from both sides. Z equals to -2. Let's rewrite our final answer. I'm going to show you guys 2 different ways that I will accept your final answer. Whoops. So one is to write it all out. X equals 7, y equals 3, and z equals to -2, meaning these are the 3 numbers that make all 3 equations work. The other way is to write it as a coordinate point. However, we haven't talked about the z-axis yet. Okay, it does exist. We will get into that in the future. However, we do just want to write it almost in alphabetical order. We're just adding the z at the end. It is our third axis. So x was 7, y was 3, z was -2. For now, whichever way you're comfortable writing it is the way that I will take it. Thank you for watching. If you have any questions, feel free to ask me in class or leave a comment or send me an email, okay? Bye!